Hi guys, we are from team dotCoders. First of all, we would like to thank Government of India for organizing such a beautiful hackathon which goes by the name KAVACH-2023. We have chosen the problem statement Citizen Safety App for protection against cybercrimes. Let me introduce to few facts such as in 2019 we came to know about 44,735 cyber frauds has been happened, and in 2020 the number raised to 50,035, and in 2021 we have noticed that 52,974 cyber frauds has happened. Thus we can see an exponential increase rate in day-to-day life, and due to which many innocent people are getting affected and lot of confidential information is getting lost. That concluded us to develop a mobile application which goes by the name Sectai, which integrates malicious SMS, mobile numbers, and UPI address and URLs and Bitcoin wallet address. Basically, our application acts as one-stop solution for all the cyber causing frauds. And our proposed system, if at all a user finds something is unusual or inappropriate, then he'll be opening our application and navigate according to his preferred choice. Navigation might be, he might on a given day he might get a call from an unknown number, or he might get a message SMS from unknown address. He will be choosing his own preferred choice. After entering the input, the architecture we have deployed in our application will try to detect whether the given input is false or not, and after successful verification he can further proceed if it is true, if it is fraud free, and if not, he might complain to any other higher authorities.
So now let's get into the architecture of the app, the basic workflow of the app, what happens in the app. So basically what we use is machine learning and artificial intelligence technologies. So what basically we have is a large data set of malicious data, such as data regarding false URLs, as data regarding the false SMS, data regarding the spam numbers, etc. like that. I think you would have got it what I mean to say about the data. So what we do is we basically train a machine learning model. By machine learning model, I don't mean that we deploy a single machine learning model for everything. We choose the best learning models that works for the best category. Like a certain machine learning model may work for a URL detection, and other model may work for the another type of spam detection kind of thing. So what we do is we train different type of machine learning models. So once the model is trained, so let me get into it a bit deeply. So once the model is being trained, it is then pickled. So after that, what we do is we use a Flask technology, which is of Python, to make it as an API, and then we use Postman to test that API. So what our application does is it indirectly runs the API behind. The model that we trained resides in the server. So what happens when a user uses a mobile application? He enters a query. The query is generated, and the same query is run on a database. So what it does is it just asks the model to predict. So think of it as this way. Our model is like wine. It gets better as it gets old, because we are using the online learning model. So the more the machine is fed with the external kind of data rather than the training data, the more mature the model will get. So this will help the user to immediately detect what all up is about the query that he is going to do. If he puts in a message, it directly spits out it's a wrong message. This is what happens in the application.
Now I would like to go through about our technology stack that we have used in a mobile application. Firstly, machine learning for deploying models for URL and SMS detection, and then Android Studio for developing our mobile application, preferably natural language processing for generating regular expressions, blockchain for generating Bitcoin wallet address, and Firebase as backend. Now let me explain use cases. At first, the user need to install or download the mobile application, and then he need to register. After entering credentials, like as mentioned earlier, navigation through his preferred choice as one of the category, he need to enter the input, and our backend architecture will predict whether the given input is fraud or not. And after successful execution of our architecture, user might know about whether the given URL is fraud or not. And the dependencies for our application is mobile for developing and testing the application, machine learning framework for deploying our machine learning models, PC with good internet connectivity to run all these tasks, Anaconda Navigator for developing our machine learning models, malware datasets. We have obtained our datasets through Kaggle, and regular expressions for generating valid mobile numbers or Bitcoin wallet address and UPI address. The showstoppers for our application is inadequate data, that we cannot completely rely upon the data we have obtained through regular expressions or through datasets. the models are always not 100% sure. They might differ in accuracies, and bad internet connectivity might stop the functionality of our application. And high traffic on the server, as mentioned earlier, we have using Firebase as a backend. The Firebase is limited to only 2000 users. Once the number goes beyond, we need to pay some extra amount. These are the stoppers for our application. Let me get back to key points of our application. It is easy to use. A person with minimal knowledge regarding mobile can utilize our application. URL detection using XGBoost classifier. Out of all the algorithms used, XGBoost classifier outperformed with 97% accuracy. SMS detection using multinomial naive based classifier. This outperformed by predicting the accuracy score of 97%. NLP for generating regular expressions for UPI address, Bitcoin wallet address, and mobile number detection. At last, I would like to thank our mentors Jyoshna ma'am and Pradeep Kumar sir for their valiant effort, and thanks for watching.